How is energy dissipation managed in sports equipment damping? Imagine hitting a tennis ball or skiing down a slope and feeling that smooth, controlled response rather than jarring vibrations. That's where damping in sports equipment comes into play. It's all about managing vibrations that happen when you impact or move your gear. When you swing a racket or land after a jump, vibrations are generated. Without proper damping, these vibrations can cause fatigue, discomfort, or even damage to the equipment. So, how do manufacturers control this energy? They use a mix of smart materials, clever design, and special devices to turn vibrational energy into heat or other harmless forms. One common method involves using materials that naturally absorb vibrations. Polymers like rubber or polyurethane are popular because they exhibit hysteresis. That means during deformation, they convert some of the mechanical energy into heat, reducing vibrations. These materials are often layered inside rackets, skis, or helmets to dampen impact forces. Advanced composite materials, such as carbon fiber reinforced plastics, can also include viscoelastic layers. These layers bend and shear when vibrations occur, dissipating energy without adding much weight. Some equipment even uses granular materials like tiny sand particles inside cavities. When vibrations shake the gear, the particles rub against each other, turning vibrational energy into heat and calming the motion. Structural damping is another key approach. Constrained layer damping involves placing a viscoelastic material between two rigid layers. When vibrations occur, shear deformation in this layer dissipates energy. This technique is common in high-performance skis and tennis rackets. Tuned mass dampers are small weights attached to the equipment that move opposite to the vibrations. They cancel out specific resonance frequencies, making the gear feel steadier. Mechanical springs and shock absorbers are also used, especially in roller skates or mountain biking gear. These absorb shocks and vibrations, reducing stress on your body and improving comfort. Design plays a big role too. Dampers are often placed where vibrations are strongest, like near handles or impact zones. For example, tennis rackets often have rubber or foam dampers near the handle to absorb shock before it reaches your hand. The placement and mass distribution are carefully considered to balance performance and comfort. Some damping devices are nonlinear, meaning they work better at high vibrations. Metal rubber shock absorbers, for example, dissipate energy through internal friction, especially during impacts. Modern engineering tools like finite element analysis help optimize damping systems. These simulations predict how vibrations behave and guide the placement of damping layers or devices. The goal is to reduce vibrations at specific frequencies without sacrificing the equipment's stiffness or weight. In sports gear like skis, damping systems control bending resonances that can cause instability. In tennis rackets, polymer dampers quickly reduce impact vibrations, making the game more comfortable. In roller skates, spring and liquid-filled dampers lessen vibrational stress on your legs. Overall, managing energy dissipation in sports equipment involves combining the right materials, structural features, and damping devices. These work together to turn vibrational energy into heat or other forms, making your experience safer, more comfortable, and more effective. Whether it's a tennis racket, a ski, or a helmet, damping helps you perform better and stay protected from the effects of unwanted vibrations.